Hi, welcome back to my channel. I'm Lauren Glenner, the creator of the Micro System 1 computer kit. It is the kit computer that you build yourself, running a virtual world that you create with your friends. So tonight we're going to go through fixing a bug in the Micro System software. I think the first thing that we're going to do is install an IDE, so it's easier to edit the code. Then we're going to install GDB, so that we can then actually debug the code as it's running. Before we start, I'd like to say a very big thanks to all of my new viewers and my 29 new subscribers since the last video. Thank you so much. If you haven't subscribed yet, please subscribe now, all the usual YouTube stuff. Now, like the last video, I've got my hot chocolate here, and I've got a snack this time, which is Arnott Scotch Finger Biscuits. Maybe this is an Australian thing. I don't know how many people have heard of this, but it's kind of like a shortbread kind of biscuit. So I promise this video is not sponsored by Arnott's. I just love eating these things. So if you haven't got a snack and a beverage yet, I'd suggest you pause the video now, go and get one, settle down and join me in this sort of chill debugging video. Let's get going. So I've got here my Debian virtual machine, which I set up in the last video, which is a sort of fresh install of Debian. And I've got over here my very special beverage and snack camera. I think in the last video we did a little bit of code editing, but it was only through the command line with a nano text editor. So I think the first thing that we're going to need to do now is install an IDE, an integrated development environment, so that we can more easily edit the code. We have a graphical editor rather than doing it in text mode. So I'm just going to pop into Firefox. So I'm going to download Visual Studio Code because that's my favorite editor. It's a Microsoft product, but it is open source. There's a lot of different IDEs. I'm sure everybody has their own preference. Please flame me in the comments if you don't. Please don't flame me, but feel free to politely disagree with me in the comments if you have your own editor. Write down below and let us know what it is. So Visual Studio Code. You know, I also wonder whether we might be able to install this as a package, which I think is VS Code. So let's first do not apt-get. We can use apt-get, but apt-update I think is the more correct way to do it. So why do we have a problem? We need to do sudo apt-update. Put in my super secret password. So this is just updating the package list from the Debian servers. And it says that we can do some upgrades. Why don't we do that? So we want to do sudo apt. We can do, I think, upgrade, update, upgrade, or dist upgrade. I think dist upgrade gives us a more fuller upgrade. So let's give that a go. We need 190 megabytes more disk space, download 313 megabytes. It sounds good. Let's go yes. We'll pull those down. Time for a beverage. Now we're generating an initial RAM disk, which means that we must have updated the kernel, so we might have to reboot the VM in a minute. Okay, so we need to reboot to boot into our new kernel, which we've just upgraded to. I'll just do that now. Restart. So where were we before the reboot? We were going to see whether we could install Visual Studio Code using the apt package manager. So let's try doing that again. Remembering that we can use apt cache, search, if I could type properly, VS Code. And I don't know that we do have Visual Studio Code in the Debian package library. So let's go and download it from the VS Code website. VS Code. The AI code editor. If you're a fan of AI. Not a fan of AI. It's just, I like editing my code myself. Download for linux.deb. Okay, and that's finished. See if we can find it in the downloads. And there it is. So we can go sudo, because it's a package, a .deb file on the hard drive, rather than something that we're getting out of apt. I think what we need to do to install it, what I always do anyway, is just do sudo dpkg, which is dpackage, -i, and then I pass it the name of the file. So downloads code. And it's installing. Add Microsoft apt repository, yes. So if we do this, it will just mean Visual Studio Code can be updated through apt, despite the fact that we installed it manually, because it will add the keys and it will add the URL for Microsoft's apt repository. So let's just go yes. And we're done. Can we get it to run? It should be under development. There it is. Okay, so let's just go mark done. We don't want to do any setup. Forget about that. Copilot. I don't want to use Copilot at the moment. We can just close that and let's go File. We're going to go Open Folder and we're going to choose the folder that has the Microsystem source code in it. This is on GitHub, the URL which is on your screen now. And the last video takes you through getting the source code for the computer and also for the server component and compiling that and getting that to run. So if you don't have that, download that now and we can tackle this bug together. Right, so that's opened. We're going to say yes, we trust the authors of this code. We're going to get rid of, let's close all of this setup stuff. Don't want to use Copilot at the moment. All right, and here's our files. Now, as for the bug, the way that I track the bugs that I have to tackle is using a Kanban system. So if you're not familiar with it, it's kind of like taking jobs and putting them into separate cards. And the cards move between columns. So you have a backlog column, which is all the jobs that you still need to do. And then you move one card into the doing column, which is the thing that you're tackling now. And then once you've tackled that card, it gets moved into the done column. So you're shifting things from the left-hand side of the board across to the right as you do them. This kind of links in with a common way of working in software development, which kind of is a mixture of Kanban and also something called Scrum, which are both kind of techniques that fit under the kind of umbrella of agile software development. So this topic is too long and complicated to explore in this video, but look it up if you're interested. But I'll bring up the card now so you can have a look at what we need to do. Okay, so the card here in backlog, let's drag that over to doing, and I can put my face on it so that people know that it's me who is working on it. So what does it say? ANSI editor cut and paste of height data off by 1 in width. So what does that mean? I think to start talking about this, we've got to go and actually have a look at the Micro System 1 computer and have a look at the graphics and how they work. So let's pull that out now. Okay, so on the bench here I have a computer and you can see that all of the graphics are character-based. It's actually based on the original fonts from the IBM PC from the 1980s and code page 437 glyphs. So especially if you're a retro computing nerd, you'll know about ANSI art. So what's ANSI? ANSI is a way to actually add codes into plain text files to give color, either foreground color or background color to different glyphs or characters. Now in the microsystem, I've got an editor where you can actually kind of create ANSI art. So for this virtual world, things like trees or flowers or paths or signs, etc. Let's jump in now and see what that looks like. So we go Control E for edit and you can select any object for which you'd like to edit the artwork. So let's try editing the tree. And there you go. So you can see that on this side of the screen we've got our colors. We can use kind of Control up and down to change our foreground color. Control left and right changes the background color that we have selected. We've got our cursor up there. We can move our cursor around with the arrow keys and you see we can kind of like we've got the characters that we could draw down the bottom. We can change the characters that are available to draw by using Tab, or if we use Shift Tab, then we can change the characters on the right-hand side. So whatever is next to the character, when you press that on the keyboard, then it will draw that thing. So if we do R, for example, it's going to draw that kind of character, just kind of messing up our tree a bit. We probably don't want to do that, but anyway, you get the gist. So let's just escape out of that, and we're going to go, no, we do not want to save it. So confirm we want to discard. So what I've actually done with ANSI art, I've extended it for the microsystem world. Because this is a virtual world and we're drawing kind of ANSI art things which you can kind of navigate around, we want to have the sort of perception of there being height and depth in the world. It's kind of 2.5D. So if I go up to this tree, I can walk behind the tree and I kind of disappear. So how does that work? Well, ANSI files can actually have metadata attached to them, which is called source. It's just spelled how you would expect, S-A-U-C-E. So the metadata is things like the author of the ANSI file, the date that it was edited, and things like that. It also has a comment section, and I've extended that comment section to allow putting in metadata that describes height in the artwork. So if I go back into the editor and I go Control E, then I can bring that up. Now if I go Control H and I go into height editing mode, then we're going to see we've got a whole range of these F, G's and B's. So what does that mean? Well, B is background, so that's something where our character will walk over the top of that. Our character is composited over the top of whatever that glyph is. If we've got G, then that's a ground tile or character, I guess you could say, and that's something where we will bump into it. It's like an immovable thing that we can't walk into, we can't go over the top of. If it's F, then it means it's something that's in the foreground, and that means that we can actually walk behind it. So it's sort of like it's hovering over the top of us. So you can see in this tree, let me just see if I can bring that a little bit closer. I'll show you this in the simulator in a minute so it'll be easier to see. But the tree parts that you can walk behind are all F's. The base of the tree is G, that's a thing that you can't walk through, and then everything else is B. So in other words, stuff that you can actually just, it's like it's not there. So the bug that we're tackling today, there's a bug in what allows you to edit this metadata, this height metadata. Let me bring this up in the virtual machine because it'll be easier to see then. Alright, so back in the virtual machine, I will bring up our terminal simulator, which is the code which is the same code as for the hardware computer that you've just seen, but it's compiled to run under Linux. So this allows us to sort of more easily debug our code in an environment where it's easier to debug. We can debug on the actual hardware as well, but we need to actually then hook up a debugging cable, and it's a little bit more complicated. It's easier to do it under Linux using GDB and then edit using Visual Studio Code, recompile and immediately run it again. As opposed to with the actual hardware, we have to recompile it, then we have to actually flash it onto the microcontroller into its memory, and then we have to debug live on the microcontroller. If we find debug, then we have to actually recompile it under Linux, and we have to reflash the microcontroller again, which is a bit more arduous. Right, so we're going to go into Micro System, and we're going to go into Terminal Simulator, which we built already in the previous video. And let's run it. So as you can see, this is the same software that was running on the hardware. It's just now running under Linux, and it's using Qt for the graphics. Now this is trying to connect to a local server which I built previously, but I'm going to try to get it to connect to the cloud server, which is the one that the hardware computer was using just a minute ago. So I'm going to get into our server list and I'm going to add that. And that's added, and we make sure that that's the default, which it is. Now, because we need to authenticate to the server using a device key and an account key. These are kind of secret keys, so the server knows who we are and it knows to let us in. Previously, we'd set up dummy ones. I'm just going to actually put in real ones now. So we go into settings, we go into account key, and we're just going to cut away from the video here for a minute while I put in my super secret keys. Be right back. Okay, so those keys are now in. I'm connected to the real server. So the world we're going to go into is called Micro School, which is kind of like a learning world where the stuff that I've already built for you, you can walk around and see what I've built, work out what you could build yourself. Knowing the names of things allows you to build them. And you can look at some of the code that I've written for some of the games, and you can copy the code so that you can create games that are like the ones I've created or make your own. So when you buy the computer kit, you get access to this learning world so that you can understand how to build things and how to code. So we're back on the same screen that we were on the computer before. If we go into the editor, we can bring up the tree, and we're going to go into height mode with Control H. And there you go. As you can see, we've got the F's for foreground, which is stuff that we can walk behind. We've got G for ground, which is stuff that we can't walk through, and B for everything else, which is background, which is stuff that we can walk over the top of. So as you see with the tree, if we walk over to the base, we're kind of banging into the, keep going right arrow, we're not moving through it, but we can go behind the trunk, we can go up behind the canopy, we can pop out there. So as you see, this is how the height mapping works. Maybe in a future video I might actually talk about how this metadata works, the source metadata in the ANSI file, but for now it's just enough to know that it exists, and that's how we define heights of things in this 2.5 dimensional world. 2.5 dimensions because it's not real 3D, but it's not exactly purely 2D, and that there is some sense of height and depth. So I think the bug that we were trying to tackle, if we remind ourselves, was that there was something wrong with that height setting. So I think if I were to go into, maybe we should just create a new object for testing rather than actually mucking up our tree. So if we go and Control E, this would usually let us select an artwork that we want to edit, but if we go O, then that will let us create something brand new. So let's go height test. And let's just make something, what are we going to do? I don't know, we could try doing some kind of like smiley face. What have we got? For solid blocks. I'm not a very good artist, so maybe if you get one of these kits and start using the system, you may be able to do a better job of drawing than I can. But let's just see if we can. This is very silly. Okay, and let's save that. When we save, it's going to go into placement mode, so we can actually place immediately the thing that we've just created. There we go. So now, as you can see, if we go and walk up to it, by default, everything is set as being background. So in other words, none of the characters have any height, and we can just walk right over the top of the characters. Now let's go back into the editor. What we probably should do too is we need to shrink down the box, because it's kind of the actual size of the thing being drawn. The black spaces aren't drawn on the screen and you can't see those, but they're still part of the artwork, which kind of makes it hard to select on the screen. So if we do this, then we reduce the size. Oh, here we go. Okay, so if I reduce the size anymore, it's going to actually chop off the top line. So we're going to use our cut and paste functionality. So we're going to go Control X, Control V, and there we go. We'll shrink that down, and we're going to shrink in width as well. Okay, and if I go into height mode, you can see what I said before, that everything by default is background. Let's just have another look at the card. Was it cut and paste of height data is off by 1 in width? Right, so this is important. It's the cutting and pasting functionality. Let me demonstrate. When we go into height mode, so let's say we make the eyes into foreground. Actually, no, let's make everything else foreground. Okay, so we've made everything foreground except for the eyes and the mouth, which are background. And gee, all of that typing of characters was hard work, so I think it's time for me to grab my beverage. Okay, that hot chocolate really hits the spot. Okay, let's save this and see what effect it has. So we'll save. Okay, so now when we actually walk up to the face, we can walk behind the face, as it were, so the things that are set to be foreground. And we can kind of pop out in the mouth and we can pop out in the eyes. There we are, because those are set to background. Now, I think the bug is something to do with the cut and paste functionality, the copy, cut and paste functionality. Let's go back into the editor. So we can select things using the shift arrow. So let's kind of just select all of the sort of area around the eye. That's what? 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. And we're going to Control X that. And let's paste it just one character across. So we'll pop it there. So what you'll see has happened is that the characters and the attributes, in other words, the foreground and background colors, have been cut and pasted. But the height data should also have been cut and pasted. So where we've cut, that was BBB, it's reverted to background, and we've got FF, F, F, F. The I is still a B. Oh, what's happened here? This is the bug, that's BBB. What should have happened is when we actually just cut and pasted that, it should have moved the height data as well, but it seems to have chopped off the right-hand column in the height data. So that's moved that whole column. That whole column of height data has moved, but this has not moved. So this looks like an off by one error, which is really common in programming, especially when we're doing loops. If the loop doesn't go the exact number of steps that it needs to go, maybe we add one or we subtract one by accident, or we forget to add one or subtract one, so the loop finishes one step before it should finish, or worse, perhaps the loop goes one step further than it's meant to go. So let's try to find the code that controls this copy and paste and cut functionality. We just minimize that out of the way for a minute. Let's go back into Visual Studio Code. So we actually have the code base is cut up into some different directories. We have the Agape directory. The operating system is codenamed Agape. And this has got some sort of common stuff in it, so networking, audio, kind of like loaders for different things. We've also got these other directories, ANSI editor, and also editor. Editor is for text editing, ANSI editing is for editing the ANSI artwork. So let's pop into there, and let's go into there. I don't like this kind of mini preview. No, I don't want the, I'd as well install the recommended extension pack. Okay. We're on a new installation of Visual Studio Code, so we might have to install some things. It's going beverage time again, maybe. Okay, let's get rid of that. We've got the C++ extension installed now. How do we turn off the minimap? Like that, we'll get rid of that. We're going to go back over to the directory view there. All right, so looking down through here, actually maybe it might make sense in C++ to look at the header file first so we can see what we're dealing with. So this is a class ANSI editor, and as you can see, here's a constructor, there's a destructor, these are the public functions that are supported in the class, and these are the private functions. So you can see that if I'm calling the ANSI editor to edit an ANSI file, I can open, I can ask it to draw itself to the screen, I can ask it to redraw itself. Consume character is when I'm kind of typing characters in on the keyboard, those characters get sent to the ANSI editor and it handles those. You can see in the private functions though, we've got things that have to do with clip copy, clip cut, and clip paste. So let's go and have a look at those. How do we get rid of this collapsing as well? I don't like sticky scroll. Let's get rid of sticky scroll. I don't like sticky scroll. Does anybody like sticky scroll? Comment down below. So this is a pretty common pattern in my code where you've got an object which is responsible for doing things on the screen, drawing things to the screen. It's modal, so it kind of takes over the whole computer while it's working, which is what ANSI editor does. And these things will implement a function called consume character. So whatever is handling keyboard I/O, whatever that happens to be, when it gets characters from the keyboard, it calls this function and it says, here's a character, do something with it, whatever you choose internally to do. I wonder whether I can change this sort of highlighting here as well. This is not, it's a bit of a different color scheme than what I've usually got. I'm not sure that I like it. I'll have another bit of biscuit and I'll try to sort this out. All right, that's better. That was going to drive me absolutely nuts. I don't like the color bracket highlighting in Visual Studio Code, but thankfully you can turn that off. Bracket pair colorization, there you go. I have my, personal way that I like to have Visual Studio Code set up. How do you like your IDE set up? Comment down below. So here we're taking a character which is being sent from the outside of this object. Whatever is reading the keyboard is telling us that there's a character that's been typed. So you can see here when Control H is typed, then we switch height mode, which you saw before. We've got our cursor key movement. We've got when we're in height mode, we can actually type F, B, or G to set the heights. Now, in terms of how do we drag a selection box? Well, when we're holding down Shift Up, Shift Down, Shift Left, Shift Right, we're calling this try drag selection. And it's taking the row and column that the cursor is currently at, it's passing it into this try drag selection, which you see says, well, if the cursor can move, then we allow the selection to be dragged, and then update selection is the thing that actually draws the frame onto the screen that shows us what we're selecting. So that's all well and good. I think the bug obviously must be in the part where dragging the frame is working just fine. Cutting and pasting the actual ANSI characters themselves works fine. It's just the height data that seems to be off by 1. So let's kind of go all the way back up to the top where we were before. We've gone a little bit too far. Where we're doing consume character. Now, here we go. Copy, cut, and paste. So where we're doing Control-C, Control-X, Control-V. So I wonder whether the problem is in the actual cut operation or whether it's in the paste operation. You know, we can probably, let's see whether we can. I'm going to have a drink while I think about this. So it occurs to me that we can probably work out whether it's in the cut, the copy, or the paste part of the code by actually going back into the simulator and trying to see whether it happens with both cut and copy. If it happens with both cut and copy, then it means the problem is going to be in the paste code. So let's try. Let's just create a new artwork. We're not going to save it, but we'll just create something foobar. Okay, and we go into the height map, we can see that everything is background by default. So how about we just create this block, and in height mode we'll just set that to all Fs, F. Alright, so let's try first copying, Control-C, and then Control-V for paste. What do we get? Okay, interesting. So we've got BBB, so we're missing a column still. Okay, let's try cutting. In fact, I think that this is going to fail also, because I think last time we cut and that didn't work. So Control-X for cut, Control-V for paste. And yeah, indeed. So, and in fact, interestingly here, it's actually, when you cut, it should actually set where you've cut back to B, back to background, but it's actually left this column here. We've got these two Fs still sitting there. So I am going to say that the problem must be in the paste code. What do you think? So let's jump out of this and back into the code. Now, clip paste. Look at clip paste. What are we doing? Okay, so we're doing clip paste height map. This might need a little bit of explaining, actually, this part up here, where we're doing mterminal.clip paste. mterminal, if I hover over that, you can see that's a terminal object. The terminal actually has a memory buffer of what's actually on the screen. And so we're telling the terminal, you know, just kind of cut something from your memory buffer in this location and paste it to a different location. With the height map, that's actually something that we're keeping inside this object, I believe. We go and have a look in the header file. We can see that we have, yeah, there. So we've got char star height map and char star clip height map. So these are character arrays. It's actually, they're two-dimensional character arrays, I think. It's effectively used as a two-dimensional array, although it's actually in memory just sort of one-dimensional array. It's not pointers to pointers. It's just a whole bunch of char. So let's go back here and look at clip paste height map. What are we doing? What are we doing? Let's have a drink and have a read. So there's kind of two approaches that we could take to debugging this kind of code. I suppose I could sit here and look at it and I could kind of run it in my head, so kind of imagine how it would execute. And sometimes that gives us a quick answer, and that's actually a really effective way to do debugging. But we can also just actually try running it in the debugger and see what happens. So maybe we might try giving that a go. We got to make sure that we have compiled a debug version of the code first so that it actually has debugging symbols. Debugging symbols will actually let the debugger know which part of the executable code kind of relates to what part of the source code. Now in Terminal Simulator, that is being compiled with a make file which is generated from this profile with qmake. And I think, as you can see, we've got config plus equals debug. So we are actually already compiling a debug version, which is good. Let's see if we can get this running in the debugger. So if we go back here, let's just get out of that, discard changes. All right, we can just X that to close that down. So the debugger that we're going to use is the GNU debugger, or GDB. GNU? Flame me in the comments. GDB. We do not have GDB installed, so let's install it. apt install GDB. sudo apt install GDB.
tricorder, medical tricorder,
and yes, we're going to accept that. Here we go. Don't even need a beverage that time, that was very fast. Okay, so GDB, terminal simulator. Okay, so we're in the debugger. We've actually got the application loaded up. You see we've got reading symbols from terminal simulator. So we're ready to execute. We've loaded up the debug symbols, but we're not running yet. Before we run, we probably want to set a breakpoint. So a breakpoint is where we can have the debugger stop the code at a particular location. And then we can do all sorts of things. But I think the thing that we probably want to do here is we want to inspect memory, so looking at the contents of memory, and then we also want to be able to step through the code, which is where we can go through the code one step at a time and we can see what it's doing as it's executing in the CPU. So we can set a breakpoint based on a line in a source code file. So how about clip paste height map? So when we're pasting it, and at the time where we're pasting the height map, the question would be, I suppose, are we just pasting the height map off by 1, or did we actually not pick up the height from the location that we cut from? Are we off by 1 there? But anyway, let's have a look here and see what we can see. So line 1368 in ANSI editor.cpp. So we're going to go break ANSI editor.cpp 1368 and run. Okay, so we're back in the micro school world again. How about let's do what we were doing before, and we're just going to start a new temporary artwork. So, foobar. If you don't know what foobar is, it's just foo and bar are just two words that you can use when you just want made up words. So let's try, let's change our foreground color. I don't know that we want yellow, let's go with a nice red. Let's make a block. And let's go into the height editor and we're going to set those to foregrounds. Get out of height editor, and just like before, we're going to cut that. So let's Control X that and let's go Control V. And now it's stopped. You see we have no blinking cursor anymore. If we go back into the terminal, there we go. We'll see it's broken. Broken? It's hit a breakpoint, would be the correct way to say it. So we're at ANSI editor.cpp line 1368. We have a look at our source code file, that's this line here. We could actually debug within Visual Studio Code itself. For whatever reason, I just like using GDB when I'm debugging this code, but maybe that's an idea for a future video. What seems important to me here is that we've got this loop, so we're going through, we've got a source pointer and a destination pointer, and we're copying memcopy, we're copying memory from one location to another. So the destination pointer is the height map, and the source is mclip height map. So I guess clip height map is the sort of temporary location where we've cut the height data, and height map is the sort of main height map for what we're editing. So we're coming out of the clipboard and we're coming into the main height map. I suppose the question is, are we actually doing enough rows and columns? I think what we did there was we did 2 by 2, I think. We look at mclip height and we look at mclip width. Let's have a look at that. So we're looping around for mclip height. So we're going to copy an entire row at a time. Let's have a look at mclip height. P for print. Mclip height. So that's 2, which I think is correct. And what about mclip width? That is 3. Okay, that's interesting. Was that actually what I selected? Let's go back and try that again. So that's 1, 2, 3 by 2. Yep, so it's 2 height. So let's Control X that again, or Control V to paste it again. See it, 2 rows high and 3 columns wide. That looks right. So what are we going to do? We're going to basically loop over here and we're going to mcopy, des pointer, source pointer, copy width. That looks correct. I don't see an off by 1 in that loop. We're going from 0 and we'll copy row, we're adding 1 to that every time we go around the loop. and we're going to keep looping while that's less than mclip height being 2. So we're going to go 0, 1. So that gives us our correct number of iterations through the loop. And then in the mem copy here, we'll copy width. Where are we getting copy width from? That's mclip width, and mclip width is 3. So there's no reason why we shouldn't be mem copying the correct amount of data from the source to the destination. So maybe, let's try to inspect the memory. Let's have a look at the, so we're mem copying dest pointer, source pointer, mclip height map plus height map source start offset. Height map source start offset. I'm going to have a drink and think about this. So let's work through this a step at a time. What are we actually doing here? So we've got two height maps. We've got the height map, which is the sort of main one, and we've got the clip height map, which is the one we're actually using as our temporary clipboard. I guess they must be the same size. In fact, we can probably confirm that. We go right back up to the top of the source code file. We can see that we're allocating memory for the height map, which is terminal height times terminal width, and for the clip height map, it's also terminal height times terminal width, so that's okay. So they're both the same size. It's just a matter of where we're cutting and pasting. So our source pointer is coming from clip height map plus height map source start offset, which is initially 0. Okay, so I guess what we must be doing is when we actually cut or when we copy, we'll copy from wherever the kind of selection box is in the main height map. Whereas when we actually put that into the clipboard, we'll put it right up into the top left-hand corner. So this is why we're starting at 0. And then the destination pointer, height map dest start offset, which is actually where we're pasting into. So y times the width of the height map plus x, and that gives us an offset into the sort of one-dimensional array, which is holding two-dimensional data. Very confusing, I know. Let's have a look at, so what are we doing here in the loop? So we're mem copying the destination pointer from the source pointer for copy width. Yeah, this still looks right. I can't see any obvious reason why this shouldn't be working. Okay, so popping back into our debugger, we can't print the entire clip height map because it's going to be quite big. It's going to be 80 times 25 characters, but we can probably look into the individual characters. So 0, 1, 2. Right, okay, so here 0 is basically the background number and 1 is the foreground number. So remember that we were actually cutting something which was 3 wide by 2 high. So we're looking here at just the first row in memory, we've got 1, 1, 0. So it looks like by the time that we've actually already got it into the clipboard, we've actually already lost a column. So, this is kind of vexing. Maybe there's a common piece of code that works with both copy and cut that actually reads out of the height memory and puts it into the clipboard. In fact, I suspect that there must be. Let's go and see if we can find that. Going back up to the part where we're handling keystrokes. Okay, so Control C and Control X, we're going clip copy or we're going clip cut. Let's have a look at clip copy. So we're going clip copy height map, clip copy, yeah, okay, so it's the same. Copy selection height map to temporary height map, copy selection height map to temporary height map, and reset cut region, okay. But it's the same function that's being called in both cases. So let's have a look at clip copy height map. So there must be a bug in this function. We're getting closer. Maybe we'll have a pause and have a biscuit. And you know, having a look at this code, I still can't immediately see what the problem is, because what we're doing here is it looks again very similar to the paste code. But what we're doing is we're creating a source pointer which is to the main height map plus height map source start offset. So height map source start offset is where our selection frame is, so it's y times height map width plus x. And our destination pointer to the clipboard plus height map dest start offset, which is 0. That looks right. So in this loop, we're looping on row, and we're going to abs y plus clip height, starting from abs y. That looks right. And in our mem copy, so we're going to destination pointers, so we're copying into the clip height map from what the source point is pointing to, which is the main height map for copy width, and copy width is selection width. So that is really weird. Why is that not working? I wonder whether we might be able to breakpoint on here and just see whether selection width is right when it's setting copy width. That would be interesting. So line 1353, let's try doing that. Break at ANSI editor.cpp at line 1353. And we can just continue. Let's hop back into Terminal Simulator, and we're going to, hang on, no, we don't want to exit out. We just want to cancel our selection. Let's just fix up the height map again so that we've got all Fs, which is what we want. Control H to get out of height mode, not escape. Escape or discard. Let's drag our selection box over that, and we're going to go Control C, and that will breakpoint. Let's jump back into the debugger, and let's have a look at M selection width. So M selection width is 2. Ah, right. Okay, this is very interesting. I don't think that's right, is it? I don't think M selection width is meant to be 2. Funny. Let's just confirm that again. 2 down. We got 1, 2, and 3 across. 1, 2, 3. So we drag a box, 2 down, 2, 3 across. Control C. Into the debugger. Selection width is 2. Okay. So that is wrong. That is wrong. So if selection width is 2, then when we do our mem copy, so we're copying memory from one place to another, we're copying memory from the main height map into the clipboard height map, we're only going to be copying for a width of 2. That is wrong. So that is our bug. So why is it happening? This kind of reminds me of a joke about debugging. Let me see if I can find it for you. Okay, so here's the timeless joke courtesy of Reddit. The 6 stages of debugging. Number 1, that can't happen. Can't happen. How is it even possible? Must be impossible. Number 2, doesn't happen on my machine. In other words, I haven't been able to make it happen. Must be a problem that only you have. Number 3, that shouldn't happen. We're moving past the denial stage here. We're moving on to, well, it did happen, but it shouldn't happen. I'm so confused. And then why does that happen? Which is engaging the programmer's kind of curious mind. And oh, I see. I think we're at the OIC stage. And now, how did that ever work? Well, in our case, I don't think that it ever really did work, but with some bugs, it kind of appears to work, but in some rare circumstances, it doesn't work. And you go and identify the bug and you fix the bug and you think, wow, that has been broken for so many years or for so many users. I'm surprised that it hasn't broken more often or it hasn't caused more problems. Anyway, back to the code. Okay, so line 1353, we know that selection width is 2 when it should be 3. M selection width. So if we look at clip copy height map and we search for where that's being called, we go back to clip copy and clip cut. So M selection width. M selection width. Right, I see. Okay. So when we're actually copying the contents of the terminal, so the actual characters themselves and their attributes, their colors, we're actually adding 1 onto selection height and we're adding 1 onto selection width. This kind of rings a bell. I think this is my kind of, do you know about poor code? Maybe I'm not going to beat up on myself that much, but confusing code. I seem to remember that the way this dragging selection box thing works is that for whatever reason, selection height and selection width are always kind of 1 less than what they actually are. Okay, I'm not going to go right back through the code because it's just going to get confusing and this video is going to be way too long, but I think that I have an explanation for why this is always off by 1. If I go back into Terminal Simulator, actually let's just continue in the debugger first. We'll continue in the debugger, I'm going to go back into Terminal Simulator and I'm going to drag my box. So I'm holding down the Shift key and I'm going to use my arrow keys. So I'm going to hold down Shift and I'm going to go down, which drags down. I'm going to do right, which drags right. Now, look what happens if I keep holding Shift. I'm still holding Shift and I go left. We kind of flip over and we start dragging the other way. So I'm not going to go through this now because it's probably going to be too complicated for this video. It's going to make the video way too long. But I think that the reason that we're always off by 1 in the height and the width for the size of the selection box has something to do with that behavior of how it flips over. I cannot remember. Maybe I should have written myself some more comments. Let's go back into the code. I mean, I think that now that we've identified that we know that it's meant to be always off by 1, and we're meant to add 1 to it every time we're using it. And I think if we can confirm that by looking through the code. So here's where we're actually increasing and decreasing it as we drag the box in try drag selection. Okay, so there it's actually being used as part of the M terminal clip copy. We're adding 1 each time. M clip height, M clip width equals selection height plus 1, selection width plus 1. Actually, I mean, interestingly, selection height, so we're doing clip height, clip width. Why are we doing that? I suppose that's because we're trying to, when the selection cursor goes away, or if we go and select a different area, then M selection height, M selection width will change, but we've actually already got something potentially cut or copied into the clipboard, so we have to keep track of the height and the width of that, which is what M clip height and M clip width does. I wonder whether we should just use M clip height and M clip width in clip copy height map, because they've already had 1 added onto them, so that might be kind of convenient. But in any case, you can see here where we're using selection height and selection width, they're having 1 added on. Down here we've got 1 added on as well, and it's kind of the only 2 places they're used, except for up here where they're being set. I reckon we may be able to fix this in a way that makes sense by just using clip height and clip width. And it would make sense that we would use those because that's our memory of the size of the thing that we've cut or copied to the clipboard. So does anybody who's kind of under the age of 30 or 40 actually remember or know what a clipboard is? Have you used a clipboard? We use this as, it's a metaphor that we use in computing, but it sort of is referencing a physical object which probably few people touch or buy or use anymore. Kind of like how the floppy disk icon is used still as the save icon in some software. And people who have never encountered a 3.5-inch floppy disk think that it's a picture of a house. Apparently I've read like the little kind of hatch where it kind of slides open to expose the magnetic media. People think it's the door to the house. So let's go and use M clip height and M clip width down in clip copy height map. So here we're going M selection width. Let's just replace that with M clip width. And do we use, where do we do our height? Oh, this is funny. So we do actually use M clip height here for the loop, but then for the mem copy, we're using copy width, which we're previously initializing it with M selection width. So that's really strange. Why did I not use M clip width there? I'm using M clip height here where we're iterating through the rows, but I wasn't using M clip width to initialize the thing that's used in the mem copy to work out the width of memory that we copy. That's strange. Anyway, hopefully that should fix the problem. We go Control S to save that. If we go back into GDB, now we can go Control C to break in GDB, and that will just stop us wherever we are. This is a neat trick. I don't know where I learned this, or maybe I was just typing randomly in GDB one day and I found this, but we can actually just go in GDB make, and it will actually recompile the code from within GDB. That's so handy because we don't have to exit out. We're going to just delete our breakpoints, which I think is del. Do we want to delete all breakpoints? Yes, we do. And let's run again. And while we're waiting for this to reconnect to the server, it might be time to have another beverage. Yes, start from the beginning. If anybody's wondering why we've got Clippy on our splash screen, go and watch Lewis Rossman's recent video about Clippy and you'll understand. It's all about ownership. It's all about the rights that we should have over the things that we buy and that we own. And that's what I want to give you with the Micro System 1 computer kit. You buy the computer, it's yours, you can hack the software, you can see how it works. Okay, so we're back in the learning world. I'm thinking for people who are watching my videos and following me, maybe I might give you the opportunity to be able to use the web version of this software or to download and install it yourself but connect to the cloud server so that you can get into these worlds that I'm showing you. Let me know in the comments if that's something that you might be interested in. Anyway, let's go back into our smiley face here. So let's have a look at the height map. We may need to fix up the height map if it got stuffed up last time when we were experimenting with it, but I don't think so. I think that looks good. So we've got B's for our eyes, and we've got B for our mouth, and we've got F for everything else. So let's see whether we can move the eye and have the height data work now. Okay, so let's drag our selection cursor holding down Shift. So we're going to go 1, 2, 3 across and 3 down. So we're going to go 3 by 3, 9 characters in total. And let's go Control X to cut, and let's paste the eye over here. All right, looks like he's got a sideways smile now. Let's go back into our height editor and let's have a look what's happened. And I think that seems to have fixed the problem. Now in the area where we cut that got turned into blank area, we have B, which is correct. So these characters, which are the ones that we cut and pasted, we've got F, and now you can see that the third column is correct. The third column is F's with the I being A, B. So let's just get out of height mode and let's save that. And there we go. Let's see whether it actually works. So we can walk behind it. The bit that we cut to background is now background level, so we can walk through that and we can see ourselves in the eyes. That is cool. So I think proof that the bug is fixed. Good work. Does that mean that we can finish the video now? Is that the end? Or would you like to see me actually install the updated software on the real hardware? I don't know. I reckon we should try to put the fixed software on the actual hardware. So for that, what we're going to need is a programming cable and a PIC programmer. So this is a microchip product that they sell to interface with the PIC32 microcontrollers to allow you to flash code onto them. So first, we're going to have to actually try to set up microchip's compiler so that we can compile the code specifically for the microcontroller. So let's see whether we can get online and do that now. Okay, let's get rid of Terminal Simulator for the time being. We can exit out of GDB. Let's stop that. We're going to close that down. And let's jump into Firefox. I think we can drag that over to the done column now, can't we? Yes, there we go. Yay! we've done a card. We're going to be staff developer before too long. Not even senior developer, we're going to be staff level developer. We're doing so well. Okay, let's go to the Microchip website, microchip.com. Now it's going to be a fairly big download and a fairly big install. We're going to install not only the compiler for the PIC32 microcontroller that we're using in this machine, but we're also going to install the entire IDE, which comes with the programming software. So it's a little bit heavy. We might be able to install only one piece or another piece if we just needed one or the other. Say we just wanted to program and we already had a hex file. We don't need to download the entire microchip IDE. But I think in this case, because we're wanting to compile and we're wanting to flash, we're just going to get the whole lot. So let's see what we can do. We want to go down to design support. Resources, tools, maybe tools. Tools. See an MPU development tool ecosystem. Development tool ecosystem. Okay, here we go. Oh, yep. MPLAB X IDE, which is what we want. So this is going to seem a little bit weird installing a completely new IDE, but I don't actually use Microchip's IDE for day-to-day development. I do like using Visual Studio Code. I believe that Microchip, though, have actually released an integration to Visual Studio Code, so you can actually do flashing of microcontrollers and you can do debugging from Visual Studio Code using their tools. But we're just going to download MPLAB X IDE because that will come with XC32 and everything that we need. So for Linux, let's go download, 953 megabytes. We're on pretty fast Wi-Fi here where I'm recording, but that's still going to take a minute, so time for another little bit of drink and a biscuit. Now that's still downloading, so I might just actually flip over to the computer here and we're going to start trying to connect up the programmer. So this is our programming cable here. We've got the programming circuitry, which is in the middle. We've got a USB cable on this end and we've got an ICSP cable on this end. So ICSP is a 5-wire system, so we've got a clock, we've got a data for serial data to the microcontroller, and then we've got 3.3 volts, we've got ground, and we've got a pin which kind of tells the microcontroller to go into a mode for programming. That's called the MCLR master clear pin. You might also see that being referred to as VPP programming voltage. The old microcontrollers needed to have a special kind of high voltage, like 12 volts, to be able to program. These new ones don't, so the MCLR pin is just used to kind of get the microcontroller reset into the correct state for programming. So I'm just going to plug this into the programming header that we've got over there. Okay, which we've done, and I'm going to plug the other end into my computer. Getting a tangle of USB cables here. And we're not using USB-C, so we have to actually get our USB-A around the right way, which is annoying. All right, there we go. So that is ready. Okay, so jumping back over to here, we have downloaded MPLAB X. Let's see whether we can now install it. So if we go into downloads, CD downloads. Downloads or downloads? We have MPLAB X as a tar file. I talked in my last video a little bit about what tar files are. So tar meaning tape archives, so getting lots of different files and putting them all into one big file, which in this case we can see if we give the -H option is 954 megabytes. We're going to try decompressing this into our downloads directory. And we hope that there's a subdirectory in here and not a whole bunch of individual files that will just explode into our downloads directory, but let's give it a go. So tar xvf MPLAB X. So it's actually, okay, it's one single very large .sh file. So this is the way that some software is sometimes installed under Linux, is that everything is kind of in this one big file, and that one big file has at the start of it some executable section so that you can just run it and it will decompress and install itself out of that single file. Let's try that. Sometimes you may have to run things as root, so using sudo. It's probably dangerous to run things as sudo. Definitely is dangerous to run things as sudo that you downloaded if you don't trust them. In this case, we got it from MPLAB. We got it from the Microchip website, so hopefully there are no viruses. The installer needs to be run as root. Okay, and I mean this is pretty common. If we didn't run it as root, it probably would have requested root privileges because it needs to be able to install in a part of the file system that is shared by all users and that isn't just in my individual home directory. So let's run it as sudo and put in my super secret password. Okay, and we're decompressing. Yes, we're in the setup wizard. Let's go forward. I accept the license agreement without ever reading it because YOLO. Forward. Consent to allow collection of anonymous information. Yeah, why not? Why not? I would like to enable product changes notices through MPLAB X. Yeah, okay. Forward. Maybe you would untick those if you're worried about your privacy. I'm not really concerned. Choose which applications you want to install. Okay, so we're going to install, we could just install the programming environment and not the IDE if we wanted to. So we could program without having the entire IDE, which is like a Java-based IDE, but let's just install everything. I think we can probably uncheck some of these though, because they're going to require a lot of space. We're not compiling for 8-bit microcontrollers, so we don't need that. We're not compiling for DS PICs or 16-bit PIC24s, so we can get rid of that. 32-bit we need because we're using 32-bit microcontrollers in the Glina Micro System 1 computer, and other devices we don't need, but we might as well just leave that ticked because it's only 4.8 megs, so let's go for it. Not sure that I have any beverage left, but if I do, now would be an opportune time to go and have some. Oh, there's a little bit. So that's just about done installing, but I think we'll just flick back to the computer for a minute, and I'm just going to show you that the bug that we fixed does actually still happen on the computer. Let's get it turned on. And we're just going to go into the ANSI editor, and we're going to edit our little smiley face. And if we go into height map mode, it's really hard to see because the contrast is not great with the white against the yellow with this camera, but you have to take my word for it that it is the way that it was on the simulator. I'm just going to actually go to this left eye here. We're just going to drag a selection box around that, and we're going to Control X that, and we're going to go across one and down one, and we're going to go Control V to paste, and go back into height map mode, and I'll just bring that up a little bit closer. You will have to take my word for it, but the right-hand column, it now does say BBB. So indeed, this is to prove that the bug still exists on the software that's installed on the microcontroller on this computer. So let's flick back over to the computer where we're installing MPLAB X, and we'll see how we went. Okay, so off camera, I did actually run into a problem installing MPLAB X, and it's because I ran out of disk space. So I only had 20 gigabytes allocated for my virtual machine, which is enough for a base install of Debian, but when you're putting on multiple IDEs and development tools, it runs out very quickly. So I'm now back. I've expanded the virtual machine disk to 40 gig. I think we see we now have, yes, 20 gig available, or roughly thereabouts. So let's try running the MPLAB installer again. Alright, so it's complaining about already having an install. This must be the broken one that didn't quite go through last time, so let's just blow that away. rm-rf-r is recursive delete. This is very, very dangerous, especially when you're running as the super user. You can easily destroy your entire system, but we'll just be very careful about what we type in. Opt microchip, and that's done. And let's run the installer as sudo again. I'm going to select the same install options as last time, so I'll get back to you in a minute when that's finished. Alright, so that is finished. It says that the UDev rules have been updated. Some distributions require you to restart. I'm not sure that we need to on this distribution. Now, it's going to ask us which compilers we want to install. We're going to say we want the MPLAB XC32 compiler for 32-bit devices. This compiler is based on GCC. To use some of the optimization settings, you have to have a license, you have to pay for that. However, we can compile the microsystem code without needing to turn optimization on. We don't need the size optimizations to make the code really small because we do have plenty of flash memory. So we can just use the free version of XC32. And it's going to download that now. I guess for people who might want to complain about microchip charging for changes that they've made to GCC or improvements they've made on GCC, I remember on the Amp Hour, which is an electronics podcast hosted by Dave Jones and Chris Gamble, that they interviewed the CEO of Microchip, who was actually explaining it this way, that it's about making sure that compilers and tooling don't become a kind of cost for the company. It becomes a situation where they can, if not make profit out of that section of the company, at least try to sort of break even on that operation. And his reasoning for that was that then Microchip can develop better tools. And I do appreciate that, because I think in companies that create microcontrollers, that create hardware, that create chips, there can be a focus on the hardware itself and less of a focus on the tooling and the software. Whereas as a software engineer, I really do want, a good IDE, I want a good debugger, I want compilers that work well. And when I've contacted Microchip, when I actually found a bug in the compiler, whether that was from GCC upstream or whether that was something that Microchip had introduced, they were really responsive about fixing that and chasing that up. So I can vouch for their support. Does seem to be fairly reasonable. So they're not a sponsor of the video, but I'm just giving my thoughts about as to why they charge and why that's not necessarily a bad thing in terms of improving the quality of the tooling. So that is done. We're going to go, yes, we accept the license. Again, YOLO. We don't believe in reading license agreements on this channel. We want to go for the free license and install, and yep, actually we can add it to path environment variable. Why not? We probably should do that. And it's installing. Just a minute. A little bit of trivia, the microcontrollers that I'm using in the Micro System 1 kit are both PIC32M microcontrollers. One is an MM, the other one is an MZ, and these use a MIPS core. If you want to know more about the Micro System 1 computer kit hardware, I'd invite you to go and check out these schematics, which I've now uploaded to GitHub. And we're finished. All right, so let's go next and finish. Now, I'm going to run MPLAB X IDE. And we're going to have to set up a project to allow MPLAB X to compile and flash our program. I'm not going to bore you with the details of this or put this in this video because once I've set up that project, I'm going to upload the necessary files onto GitHub. So by the time that this video goes up, you'll be able to just simply open up the source code directory and it will be all ready for you. So I'll cut away for a minute and I'll come back when I've got that working. Okay, and we're back. So if you have a Micro System 1 computer kit, after you've installed MPLAB, what you're going to do is you will open it up, you will go File, Open Project, and you're going to want to go to where you've checked out the Micro System source code from GitHub, and you're going to want to click on the client directory and then go Open Project. So what we will see here when this opens up is the type of microcontroller is PIC32MZ2048EFG064, and we can see that I've selected as my programming tool as debug tools none at the moment. We might just make sure that we've got our PIC32 set up. Let's go Tool, PIC32, which is plugged in, which is over here. I've got this camera view set up now so that you can watch the computer and you can watch the programmer as we're programming the microcontroller. I'm going to go OK. So you'll go up into the menu bar up here and you'll go Build for Debugging. So it doesn't really matter if you go Build for Debugging or Build, because either option is going to run the make file from that client directory, and so it's going to use whatever flags are in there, which are currently set up as debugging flags. We'll just leave that to compile for a minute. There are quite a few compiler warnings, but I like to think of them as suggestions. Okay, so that has succeeded. Now the moment of truth. Let's see whether we can use the MPLAB 4 PIC32 to program this into the flash memory on the microcontroller. So what we want to do is this little thing here up in the top bar, which has got an arrow pointing down to the chip. We want to go Make and Program Device. We don't need to do that because we've already made, so why don't we just go Program Device. And we're going to select PIC32, yes, and is it going to work? No, it is not going to work. Okay, let's try again. This may just be an issue running the PIC32 through a virtual machine. I've just disconnected the virtual device and I've reconnected it now. So let's go OK. And hello, something's happening. Yes, no, maybe. I think it's updating the firmware on the PIC32 programmer to the latest firmware. So we'll just give it a minute to do that. Okay, so it's complaining about not being able to find target power. I'm just going to actually check the connection and make sure I've got the connection right. Sometimes I can just put it on the wrong pins on the header and then it doesn't work. So just a minute. Okay, let's try again. It's erasing. It seems to be working. Programming. Very exciting. If it works, you should see the screen on the computer blank out and we'll go back to the splash screen. Insert dramatic music here. Complete! Is it going to restart? So I think I realised what I've done wrong. It doesn't matter what option you choose when you're compiling the project, whether that's the debug option or the production option, because both options run the make file in the client directory, and that does the same thing. But I think that it matters which programming option you choose. So I chose Program Device for debugging. I think what that does is it will cause the computer to actually sit in a suspended state, this computer, until such time as the debug GUI connects and expects you to then to step through the code or to let it run. We don't want that. We want the computer to just be able to free run on its own. So we're going to try the first option, which is just Make and Program Device. Select our PIC32. Okay, it's already built, so we don't have to rebuild. Connecting to the programmer. Okay, we are programming. Come on, splash screen. Programming's complete, and yes, splash screen, it boots. Fantastic. Let's see if it works. I'll tell you what, at this point it better work because I'm all out of biscuits and I'm all out of beverage. Let's try going Control E, and we're going to go and look at the height map. So again, this is going to be a little bit hard to see, I apologize, but around the eye we've got F, 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 and we've got B in the middle of the eye. Let's get back into that editor again. Alright, so we're going to highlight the area around the eye, hold down Shift and use our arrow keys, and we're going to go Control X to cut, and we're going to go Control V to paste. And we're going to go back into height map with Control H, and do we have a good third column? We do have a good third column. It's going to be hard to see, but it is FFF down that third column, so that is the bug fixed. So, feeling pretty good about that. So I think that's it for this video. That's one bug down. In software development, there are always more bugs, but that's part of the fun. So I'm going to put up that fix onto GitHub, so by the time this video comes out, that will already be up there. You can go and have a look on my GitHub and you can see my commit message and see what I changed. So thank you again for watching. If you haven't subscribed yet, please subscribe now so you can catch my next video. Please like, please comment, all the usual YouTube stuff, and I will see you next time. Any ideas for another video, again, feel free to post down below. We may fix another bug. Maybe we might do something with the hardware next time. Thanks for watching. I'll see you on the next video. Bye. What did I just do? Whether that's the debugging option or the... Bugger. We can now see it tells us how much program memory we have used, which for some reason is 0. What the f***?